Okay, so there's a game where people are charged $16.50 to spin the spinner below, the spinner here. All 8 spaces are the same size. People get to win whatever dollar amount they spin. So notice there's different dollar amounts. You can win $7 or 4, 7 or 4, $95 if you get that spot, and then a bunch of other 7s and 4s. Okay, so how do we do this? Well, they want expected value. How do we do expected value? Well, here's the formula from the notes. Expected value is probability times value plus probability times value plus probability times value, etc. Just multiply each probability by each value and add them up. So let's do it. So I'm going to start. It doesn't mean you start wherever you want. I'm going to start right here. So I'm going to take, oh, and what's the probability? Well, each of these is going to be 1/8, huh? Because there's 8 spaces all the same size. So there's a 1/8 probability, 1/8 chance that the spinner is going to land on that 4. So I'm going to take 1/8 times $4 plus, and then next I'll just go around the horn here. There's going to be a 1/8 chance we're going to land there times $7. And do the next one plus, well, 1/8 multiplied by another $4. And then what comes next? This one. That's the big one there. There's a 1/8. There's a 1/8 chance of that times $95, right? There's 1/8. I forgot to put the 1/8 there. There's 1/8 for all these. They're all going to be 1/8, aren't they? Plus, I'll come down here. This one also has a 1/8 chance. Another $4 slot there. Plus, and then this one has a 1/8 chance. Times, what's that, $7? Plus, this one, another 1/8 chance. And the last one here, plus this one, 1/8 as well, times $7. So there's this is the expected value. So hit the buttons on your calculator. So it's just 1/8 times 4 plus 1/8 times 7 plus 1/8 times 4, all the way around. You know what? You also, if you want to make it easier, you could have lumped them together. Either way, it's fine. You could have said, look, how many $4 ones? There's 1, 2, 3. There's 4 $4 ones. So that's 4/8 times $4. This would be a little quicker. You don't have to do this. And then you can say, how many $7? 1, 2, 3 $7. So there's 3 out of 8 is the probability of the $7. And then finally, you have the 1 out of 8 for the $95. That'd be a little quicker, just lump them together. 4 out of 8 is the probability of getting a $4. 3 out of 8 slots are the $7, and 1 out of 8 is the $95. That way, it's a little quicker on your calculator. Either way is fine. It'll come out the same. Either way you do it. So I'm getting an answer. Let's see. I'm getting $16.50. So in other words, what that means is that on average, I expect to win $16.50. So you think, well, that's where you're not going to win 60. You're going to win $7 or $4 or 95. Right, that's true. But sometimes I'll win 7, sometimes I'll win 4. Every now and then get the $95, and that'll make the average come out to be $16.50. That's what expected value is. It's the average amount you're going to get. So now it says up here, is this a fair game? Well, mine, they charged $16.50, so that's the same. So yeah, yes, mine is a fair game. Why? Because the expected value, which is $16.50, what I expect to win on average, equals the cost, which is also $16.50. So they're charging exactly what they know you're going to win on average. This is what the casino does not do. they always make the cost higher. That way they know they're going to win money in the long run on average. Does this make sense? So when the expected value equals the cost, they're charging exactly what you're going to win on average to play the game. So that makes the game totally fair. Now, if yours is not equal, then it's not a fair game if those are not equal. There we go.